In today's video, we'll be solving some questions from linear momentum and collisions. Okay, so we'll start with the first one, which reads car 1, okay, was sitting at rest when it was hit from the rear by car 2 of identical mass. Both cars had their brakes on and they skidded together for 6 meters in the original direction of motion. If the stopping force is 0.7 blah 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 combined weight. In other words, if the stopping force has the coefficient of friction being 0.7, find the approximate speed of car 2 just before the collision took place. Just before the collision took place, what was the original velocity for car 2? Well, let's identify first. What type of collision is this? Is it elastic or inelastic collision? Well, this is inelastic collision because after car 2 hit car 1, they skidded together, they were together. Okay? Solution. So in both elastic and inelastic collision, momentum is conserved. Okay? So we're going to use the formula for conservation of momentum by saying the initial momentum for car 1 plus the initial momentum for car 2 is equal to the final momentum for car 1 plus the final momentum for car 2. Wait here, wait. I know you're asking yourself, why? Wait, I'll explain. Okay, I'll explain, yes. So here, I've got MV, right? But this is the initial, so it's good to use U. Okay, plus MU for car 2. This is the formula for momentum, right? Yes, so, okay. Then here, we're going to ask ourselves, okay, actually, these cars, like, it was like this, right? Then maybe this one, yeah, okay. So this is the direction of motion. This car hit this car, okay. Then they skid together. It's more like they become one thing, right? They will be moving with the same velocity. So this side will not have two velocities, no. Rather, we'll have one velocity for the entire system. Therefore, we are going to have the final velocity for car 1 and car 2. Right? What will happen to their mass? Their masses would have combined, right? More like we are adding. So since they have got identical mass, so we are going to say the mass for car 1 is m, the mass for car 2 is m. So when we add m plus m, we are getting 2m. So we are going to add m plus m, which will give us 2m. Okay? So again, car 1 was sitting at rest, meaning that its initial velocity was 0. So its initial velocity was 0. So 0 multiplied by anything is 0. Like multiplied by m, 0. So this side will remain with this part. So m plus 2m. So 2m, quoting this velocity. But remember, let's take note. Remember that this velocity is the velocity immediately after these cars are together. This is the velocity. Okay. Then from there we can just say over m, get rid of m. Therefore we have an equation which will be the initial velocity of car 2 is equal to the velocity of car 1 and 2. Alright, but this part I don't know how I can explain it, but I feel it's good to use initial, right? Why am I saying it's good to use initial? I'll explain. Just wait, I'll explain. These cars, after sticking together, they moved a distance of 6 meters, then they stopped moving. So considering this scenario, okay, immediately after collision, it has got this velocity, right? Then after 6 meters, it has stopped moving, right? So in this case, here we're going to put U, the initial velocity for these two cars, because at the end, the final velocity will be 0, meaning that the initial here, okay, immediately they collided. That is where we are focusing, right? Yes. So immediately they have collided immediately after collision. Then immediately after collision, their initial velocity is this. Their final will be 0. Okay. With that said, we proceed. And so we can call this as equation 1, because there's nothing we can do there. What else do we know? We know that after collision, there will be change because their brakes were on. Both the cars, right? They had their brakes on, meaning that there's got something to do with friction, as you can see here, coefficient of friction, right? So from this as our starting point, in other words, right, to the end point, what was happening? Well, there was lost, okay, or there was loss of kinetic energy. Kinetic energy was being lost. due to the friction force of the brakes of both cars, right? So therefore, we are going to use the conservation of what? The conservation of energy. Change in kinetic energy. Okay. So for example, let's just give an example. Let's say here the two cars are 10 joules. You know, they can't have 10 joules, but it's an example, you get. So they have 10 joules, right? When they stop, the kinetic energy is 0. There is no motion. Kinetic energy has got something to do with motion. There is no motion. So now, for this change to happen from 10 to 0, what was really happening? Okay, where did the 10 joules go? The 10 joules went to friction, right? The 10 joules went to friction, meaning that friction force did work on this system and it got that 10 joules. In other words, we are going to see the change in kinetic energy. Okay, the change in kinetic energy. The change in kinetic energy is equal to the work done by friction. The work done by friction. Okay. What else do we know? What else do we know? Well, we know that what we are talking about is the entire system now, right? So the velocity is for both cars, car 1 and car 2. The final velocity again for car 1 and car 2. But without wasting much of our time, we can cancel out some things from here. How? This is our initial point. This is our final point. Here, the cars have stopped moving. What is the final velocity in that case? The final velocity in that case is 0. The final velocity is 0. Therefore, this part is no longer important to us. Okay? Yeah. This part is no longer important to us. What about this negative? This negative, well, simply shows that energy was being lost. Therefore, it's no longer it's not important as well to us. Okay, for our solution, because it simply shows that, oh, this energy was lost by what? By friction. So therefore we have 1/2. Then we have got mass. 1/2 multiplied by mass. Okay, the mass for the entire system is 2m. So the mass is 2m multiplied by this, right, square, is equal to the work done by friction. But now, how do we find work done? In general, work done is equal to force times distance, right? But in this case, this work done is the work done was done by friction, right? So it will be work done by friction is equal to the friction force. Yes, the friction, because it is the work done by friction, so it's equal to the friction. Yes, okay, amazing. Wow, we have this. Okay, so here we are, just by seeing, okay, we can get rid of these two and this one, and we have mu squared for the combined cars is equal to the work done. So the work done, we've said, is force of friction, right? Force of friction is also negative. Even if we were to put a negative here, it would have cancelled with that one, but no, for now, it's all about understanding the concept. Okay, force done, yeah. Okay, friction force times distance. Again, we ask ourselves to say, how do we find the friction force? Well, friction force is equal to coefficient of friction multiplied by the normal. We replace where there is friction force with this. Okay, so friction force divided by the normal distance. Again, we ask ourselves to say, have we been given the normal? No. How do we find the normal in this case? In this case, the normal is simply equal to the weight of the system. What is the weight of this system? Well, the weight of this system is equal to mass times gravity. What is the mass of this system? The mass of this system is 2m. Therefore, the weight is equal to 2mg. Since the weight is equal to the normal is equal to 2 what? 2mg. So come back here again and replace. Okay, we are replacing again. This is amazing. This is amazing actually. Okay, so where there is this, we replace with 2mg, then multiplied by the distance. Okay, all right. From there, we can make use of this part. Let's make use of this part actually. Okay. From there, here, we can now replace. Okay. But before we replace, we can just get rid of the m. This m and this m. Like we divide over m over m. Then, get rid of the m. What do we remain with? Well, we are going to remain with u squared for both cars. What is the coefficient of friction? Okay, so before we even do that, we can just say coefficient of friction 2 gt, right? And just say this square root. So the initial velocity for the two cars immediate after collision is equal to, what is the coefficient of friction? 0.7 multiplied by 2. Gravity 9.8, but stick to your school. Multiplied by, follow what your school wants. Multiplied by the distance is 6 meters. Here. Therefore, multiplying and getting the square root of the answer gives 9.073036979, depending with your calculator. Okay? Yeah, but 9 is giving you this one. If it's not giving you this one, then try to reset it. Yeah. Or repunch. Okay. Repunch. Amazing. Okay. Then we have this. Okay. So we can again have this part. And now conclude. Find the approximate speed of car 2. So they want the speed for this car. So before the collision, this was the speed for car 2, which is given by 2. Have you seen? 2 this, right? So where there is this, replace with what we found. So it is 9.07, blah 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 blah. Yeah, you include those numbers, right? So this multiplied by 2, getting 18.14607.395. Therefore, the approximate speed of car 2 just before collision, okay, is 18.1 meter per second. This is our solution. Okay. Let's move to the next question. Well, this is our second question, which reads, a bullet of mass 10 gram and traveling at a speed of 500 meters per second strikes a block of mass 2 kg, which is suspended by a string of length 5 meters. Yeah. The bullet goes through the block in a very short time, and the center of gravity of the block is found to rise a vertical distance of 10 centimeters. The length of this is 5 meters. Okay. What is the speed of the bullet just after it emerges from the block? It emerges after it emerges. So now, let's identify, attention, people. Attention. Is this an elastic or inelastic collision? Well, this is an elastic collision because the bullet emerged out of the block. Okay. Therefore, here's our solution. Okay. Momentum was conserved. So the initial momentum. So I've got what? I've got a bullet of mass this traveling at the speed of this, strike a block. Okay. BB block of mass 2 kg by a string of length what was suspended, meaning that it was at rest. Okay. Great. So the initial velocity, so the bullet will be represented by B, okay, by capital letter B. Yeah, let's put capital letter B for the bullet. So the initial momentum for the bullet plus the initial momentum of the block is equal to the final momentum of the bullet plus the final momentum of the block. How do we find momentum? Momentum is given by m multiplied by the velocity, right? The change in velocity. Okay, in this case, you're putting this plus initial again for the block, which will give us the final, again the final for the block. Well, this thing was at rest, right? Which is the block was at rest, meaning that its initial velocity was 0. So once we put the 0 here, everything will be 0. In this case, this side will only remain with this mu. Okay, is equal to, what about for this side? This side will have m e f plus this. Okay, This is amazing. It's amazing. Okay, so we can replace now. We can replace. I know people are like, why not replacing? Let's replace now. Let's replace. Let's replace. Mass. What is the mass of the bullet? Well, the mass of the bullet is 10 grams. So you can convert that to kilogram. And converting, you only divide by 1000. Therefore, the mass is 0.01 kg. Multiplied by the initial velocity of the block of the bullet is 500. Okay, is equal to, what is the mass of the block? Well, the mass of the block is 2 kg. So we're not converting because it is already in kg, right? Multiplied by, what is the final velocity of the what? Of the block? Well, the final velocity of the block we don't know. We don't know. Plus mass, yeah, for the bullet is the same. So now they want us to find the speed. This is amazing. The speed of the bullet just after it emerges from the block. Okay. From this formula, this is the speed they want us to find. V FB. But now, looking at the formula, you realize that we have got two unknown things, two unknown stuffs. Okay. First, let's multiply. Multiply gives. So once you multiply, you have 5 is equal to this 2 0.01. We want to find this, but we don't have this. So how can we find this? Which is the final velocity of the block, or the velocity of the block immediately after the collision took place? Well, we are going to use the change in energy, how energy changes on a pendulum. Okay, right? So when you have got this thing here, let's say we use maybe 100 joules. Okay, so the potential energy here will be 100. The kinetic here will be 0 at the middle here. Then potential energy will be 0. Okay, the kinetic energy will be 100. Or will be maximum. Okay, the potential energy here will be maximum. The kinetic will be 0. Same thing applies here. Okay, same thing applies here. The kinetic energy in this case will be maximum. The potential will be 0. Here, the potential energy will dominate. Will be maximum. Okay, the kinetic energy will be 0. Okay, this one will be dominant here and here. The kinetic energy will only be dominant here. Okay, but what can you notice? Okay, what can you see? Well, if you can't see it, me I can see that the kinetic energy at this point is equal to the potential energy at this point. Therefore, I'm going to say the kinetic energy, okay, which is given by this squared, right? The kinetic energy at this point is equal to the potential energy. Okay, so why not try this? Kinetic energy at this point is equal to potential energy at that point. Then the formula now, right? Yes, kinetic energy of the what? Of the block, because we want to find the value for the what? The velocity for the block. So that we replace here. After replacing now, we can find the speed of the bullet just after it emerged from the block. Amazing. This is amazing. Let's continue. Well, what is the mass of the block? Okay, so this one is the same as the FB after collision, right? So this is the same, right? Amazing. So what is the mass for this, for the block? Mass for the block is 2 kg. Okay, yeah, the mass for the block is 2 kg. Gravity 9.8. What is the height? The height is 10 centimeter. Okay, so 10 centimeter over 100. Convert the centimeter to meters. 1 meter is equal to 100 centimeters. Okay, what about for mass? 1 kg is equal to 1000 grams. Convert, don't forget, convert. Okay, therefore converting gives 0.1. So this and this goes right. So square root of this, square root of this. Therefore the velocity is equal to, 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 the velocity is therefore equal to, the velocity is therefore equal to 1.4 meter per second. Wow, this is the same. This is what you have also found. This is amazing. So we found the velocity. This. So we can just replace. So we say 5 equal to 2. What is this? 1.4 plus 0.01 VFB. Okay, we can now get rid of this part. So yeah, 5 this by this, okay, by 2 is 2.8. So this is 2.8. Then yeah, if yeah, it's fine. 2.8. Yeah, I wanted to, but yeah, it's fine. Okay, so 5, yeah, you know what I mean, is equal to 0.01. You know what I mean. 5 minus this gives 2.2, is equal to 0.01. Okay, then divide over 0.1 over 0.00, yeah, 0.001 actually. The velocity of the bullet is equal to, so 2.1 2.2 over 0.01 gives 220 meter per second. Therefore, the speed of the bullet just after it emerges from the block is what? Is 220 meter per second. Let's move to the next question. Next question. All right, this is the third question. Question number 3 reads: a billiard ball at rest is struck by another billiard ball of the same mass whose speed is 6 meters per second. After an elastic collision, the striking ball goes off at an angle of 25 degrees with respect to its original direction of motion. Find the angle the struck ball makes with this direction and the speed of both balls. Right? So obviously, looking at the question, you should be able to understand to say this is coming from balancing collisions. Yeah, probably I'll make a video on that, explaining that, but this is balancing collision. Yeah. So let's take note of some things. Let's take note of some stuff. Okay, so they are saying the billiard ball at rest. So one is at rest, not taken. Another billiard ball of the same mass, not taken. Whose speed is this? Okay. After an elastic, have you seen? We have got it. One is at rest, one is moving. Okay. We have got the same mass, and it is an elastic collision. If we have got these 3 conditions, pay attention. If we have got those 3 conditions, then despite of the speed, the angle which will be between these 2 balls, in this case balls, is going to be 90 degrees. Take note of that. Okay. One is at rest, one is moving. They have got the same mass, and the type of elastic collision they are in is elastic. Okay. They have an elastic collision. Just know that the angle between those two things, okay, is 90 degrees. Right? If you want, you can use a diagram actually. Okay. Yeah. That's it still works actually. Yeah, it depends with which one you're okay with. But immediately from this, you need to be able to tell. So okay. So one went. So after elastic collision, the striking ball goes off at an angle of. So the striking ball is the one which had the velocity, right, which was moving. It is the one striking another ball, right? So after this, the strike took place, this went. So for example, if I put something like this, then the other one was at rest, then blah blah blah. What do we know? We know that after the collision, okay, after the collision took place, the striking ball went at an angle of 25 degrees. Okay, 25 degrees. But we know that the angle between these 2 balls, because of due to those conditions, is supposed to be 90. So it's supposed to be 90. Okay. So let's name this. We had bought rest. Okay, so the first one will be at rest, the second one. Okay, great. Okay. Yeah. Take note of this. We'll come back to this. We'll get back to this. For now, let's derive a formula. Okay. For now, let's derive a formula. Well, on balancing collision, we need to take note that we consider the x-axis independently and the y-axis independently. Okay. How can we find this angle? We know that the total angle is 90, right? So 90 minus 25. What are we getting? 90 minus 25. We're getting 65, right? So the angle here is 65. So now, These same two balls will have components, right? Will have components. They'll have the x component and the y component. So for this part, the x component this one, the y component is this one. For this part, the x component and the y component. Let's start with the x component. Let's start with the x component. So they are asking us to find what? Find the angle the structure ball makes with this is the angle. We've already found it. Find the angle the structure ball makes with this direction and the final speed z. So the angle we've already found. Yeah, there are different ways of getting it right. Okay, that is the angle. So therefore, in the x-axis, we are going to say the initial momentum. In the x-axis, the initial momentum of this one, which was at rest, I'll just put r plus the initial momentum of the other one, which was moving, which I'll call b, is equal to the final momentum of r plus the final momentum of b. Amazing. Okay, but one was at rest. One was at rest. Anyways, we meet that. Okay, one was at rest. One was moving. What does that supposed to mean to us? What does that supposed to mean to us? They are the identical masses, so we'll just use m, identical. Okay. Right. This one was at rest, meaning that its initial velocity was 0. 0 multiplied by this, 0. Okay, we are good to go. This. Okay. Before we proceed, if you want, you can just say this side you factorize m, then divide over m, you still get rid of the m. Then I've got the initial velocity, right? Yeah, you remain with the initial velocity, which was 6. So you can just replace there and then. It will be 6 is equal to the final velocity of this ball, which was initially at rest, plus the final velocity of this ball, which had an initial velocity of 6 meters. This is our equation 1 from x-axis. Okay, but before we conclude that this is our equation, let's put the angles actually, because this is this, like we are in the x component. We are in the x component, meaning that how do we find the x component? Well, for us to find the x component, we just say this cos theta, right? Cos theta. But these angles are different. Okay, these angles are different. When we come here, which one was initially at rest? The one which was initially at rest is this one. So this one is the VFR. This one is the VFB. Okay, so this will have a component here. So how can we find this component, which is the x component? Its x component is to say VFR cos 65. This is what we've done here. Okay, so in this case, the theta for this one is simply cos 65. Okay, this is our first equation. Are we done? No, we are not done. Yeah. Thanks for the reminder. We are not done. Plus, how do we find the x component for this one? Okay, its x component, this one, we are going to say VFB, right? VFB cos what? Cos 25. Okay. So 6 is equal to VFR. It's just one and the same thing. Don't rub. Why are you rubbing? Why are you rubbing? Don't rub. Cos 65 plus VFB cos 25. Okay. This is our equation 1. Let's get another equation from the y-axis. From the y-axis, let's get another equation. So how do we find the components from the y-axis? Okay. So for the y-axis, we're just going to be a bit quick. Okay. So we get the same thing, right? So it will be this plus this is equal to. Right, amazing. Okay, but now initially another ball is not moving, another one was moving. Okay, so you can just say this one was something like this. So initially these balls were moving like this, we're moving in this direction. like this horizontally, did they have the y component initially? The answer is no. The answer is no. The answer is no. Initially, they never had the y components. Therefore, this part becomes 0. This part becomes 0. Oh. Then you realize that when you draw this diagram of yours, find that for this component, the y component will be pointing in this direction. Then this one will be pointing in this direction. So they will be kind of against each other, you know. Okay. In other words, you can just say, okay, this is the horizontal. Okay. The upward part is always the positive. The downward part is the negative, because momentum is a vector quantity. Okay, meaning that we need to take note of the direction. When you are moving in this direction, then probably you have a negative sign, right? Okay, cool. Therefore, that being said, we have got this, right? Yeah. The So this one, how can we find this component? Well, for this component which is moving in this direction, I've said it will have a negative sign, right? But how do we find the y component? So the y component for this one, by the way, this is coming from SOHCAHTOA, just SOHCAHTOA, right? So the y component is simply VFR sin theta. In this case, the theta is 65. Okay, yeah. So for this one, it is the V. Okay, FR. Okay, we're still on momentum, right? Yeah, we're still on momentum. Okay, great. One and the same, one and the same, one and the same thing, one and the same thing. Okay, this is one and the same thing. Okay, all right. I was looking ahead actually. Okay, so for this one, this velocity, we say that since it is moving in this direction, it will have a negative sign. Okay, like it will have a negative sign, which will affect everything it has, right? Then let's bring it this side. It will be this. Right? You can get rid of the masses because they are just one and the same. Therefore, you have this. But since we are finding this component, it's not the entire thing. No, we are finding this component. How do we find this component, which is the y component, multiplied by the sine angle. This angle is sine 65, right? So sine 65 is equals to, what about for this component? This component. Well, for this component, easy. VFB, right? Sine 25. Okay, sine 25. So from here, you can just see, okay, is this visible? Okay, yeah, easy. Excuse me. Okay, so from this, you can make either of the two the subject of formula, right? So let me make VFR the subject of formula. So I have over sine 65 over sine 65. Therefore, VFR is equal to VFB sine 25 over sine 65. This is my second equation. Yeah. My second equation. So I've got two equations. I've got this one. Okay. I hope you are able to take note. I've got this equation and that equation. So I can just get this equation. Okay. Yeah. So I'll say 6 is equal to. Okay. So where there is VFR, I replace with this one. So here there is VFR, right? So I'll replace with VFB sine 25 over sine 65, right? Multiplied by cos 65 plus VFB cos 25. Okay. From there, the punching can be done. The punch collective. Okay, punch collective. So I'll punch sine 25 over sine 65, right? Multiplied by this. Okay, so I'm saying sine 25 over sine 65 multiplied by cos 65, and I'm getting 0.197070132. Are you also getting the same thing? Is this what you are also getting? Well, that's great. If this is what you are also getting, then this. So what is cos 25? Cos 25 is 0.91. What multiplied by this? We have 0.906 907787 VFB. Okay, so I can add the two because this is VFB, this is VFB, so I can just add the two. So 0.9 what plus this plus this plus this. Same thing. 0.197070132. I'm getting something like 6. Getting something like 1.103377919. This is VFB, remember? Over the same thing. And this side over the same entire thing. Once you cross multiply, then VFB will be equal to 6 over 6 over this. Your answer, which will be 5.437846722. Okay. The final velocity for the bullet is therefore equal to, so this is the final velocity for the bullet. Okay, is it the bullet? No. Yeah, for the billiard ball which was moving. Kind of continues to dealing with bullets. Yeah, because of something like that. But yeah, bullets. Okay, so this is the final velocity for the billiard ball which had an initial velocity of 6. Well, so we have this, right? We have got this. We also have got the angle 65. We are only remaining with one thing, right? What is that? It's the final velocity for the billiard ball which was initially at rest. How can we find that? By replacing in either of these two equations. We can use this or this one. Which one should we use? Which one? Okay, this one, because it is already the subject of the formula. So we have got the VFB. What is VFB? Is this one. So 4 points. So I'll use this one. 3 multiplied by sine 25 multiplied over sine 65. So that multiplied by sine 25, the answer over sine 65. And I'm getting something like 2.5357095570. 5. Therefore, you can say, now you can plug this in. Therefore, what? Therefore, the angle and the final speed of both balls. So the angle is this one. The angle is 5 degrees. The final velocity for this ball is this, and the final velocity for this ball which was initially at rest is 2.54 meter per second. So this is our solution. Let's move to the last question for this video, question 4. All right, the last question for this video reads: a vessel at rest explodes. But why should a vessel explode? And we don't know, but it exploded actually. Yeah. So a vessel at rest explodes, breaking into pieces. 2 of the pieces with masses. Yeah. So 2 of the pieces with masses M1 and M2, where M1 is equal to M2, fly off perpendicular to one another with the same speed of 30 meters per second. The third piece has mass, mass M3, which is equal to 3M2. Find the magnitude and direction of its velocity just after the explosion. So they are asking us to find the magnitude and the direction of its velocity. Whose velocity? So we are dealing with it, the third one, because the first one, the second one, we've been given everything. So we are finding the magnitude and direction for the third mass. Well, let's take note of some stuff. Okay. What do we know? We know that I've got 3 things, right? Okay. So I've got this one, this, and this. Okay. So I've got 3 things. This is a 3D question, 3-dimensional question. Okay. Is it necessary to write it that? Maybe. Let's start with the formula. Conservation of momentum. Momentum is this concept. Okay. So the initial momentum. Okay. So initial momentum of the first mass plus the initial momentum of the second, the initial of the third is equal to the final This statement is very important. Okay. A vessel at least, meaning that the initial velocities, these initial velocities are 0. Okay. So this part zeros. Okay. So 0 is equal to So now we have got something like perpendicular. We'll look into that right away. Okay. So yeah. This was the mass and velocity for the first for this one. Okay. So this is the final pricing for the second one. Yeah. Amazing. Okay. Right. So now let's interpret some things here. Okay. They're saying that these masses fly off perpendicular to each other, meaning that between them, the angle between them was 90 degrees. Yeah, so you can interpret it in whichever way, right? But in this case, we just say, just take it as the other one went along the x-axis. Yeah. So we say the other one went along the x-axis, and the other one went along the. So the other one went along the positive x-axis, and the other one went along the positive y-axis. That will be our interpretation. Okay. Yeah, but we know that since that was something to do with angles, then it is from Ganssing collisions, right? Meaning that we need to write separately the conservation of momentum in the x-axis and in the y-axis. Okay. So this one is okay. So we'll call this as M1. This M2. Okay. So in the x-axis, what do we know? Okay. In the x-axis, we'll get this same thing, right? And just replace some stuff. No? Yeah. I think we can switch on our data from here. So what is the mass for M1? What is the mass for M2? And what is the mass for M3? Well, M1 is equal to 2 M2. Meaning that if M2 is M, right? Okay. Meaning that if M2 is M, this is the interpretation, right? So if M2 is M, meaning that M1 is equal to what? 2M. If M2 is 10, meaning that M1 is equal to what? Is equal to 2 times 10, which will be 20. Okay. What is M3? M3 is equal to 3 M2. That's the thing. Okay. We now proceed. So 0 is equal to, what is the mass for M1? Mass for M1 is 2M. The velocity for M1, these two have got the velocity of this, M1 and M2, 8. So this multiplied by 8. Okay, so should we replace, or maybe I bring this down? Okay. For the sake of peace, let me bring this down. Okay. Let me bring this down for the sake of peace. Alright. Okay. So for the M1, the mass is 2M. The velocity is 8. Okay. After explosion, right? Yes. Plus. What about for this one? Its mass is just M. Multiplied by velocity is 8. Plus this one now. Its mass is what? 3M. The velocity we don't know. We don't know the velocity. Okay. We don't know the velocity. But now we are in the x-axis. Please take note. We are in the x-axis. Okay? We are in the x-axis. I know some people one time say, oh, why did you do this? Yeah. We are in the x-axis. For this part, which is the M1. How do we find the velocity in the x-axis? Which is the same velocity here we've taken to be fit as the entire thing. Okay? Well, it will still remain 30. But how? It's like this. 0 is equal to, that is 2M, right? Multiplied by, how do we find the velocity in the x-axis? We are in the x-axis. It's more like applying vectors, right? We are applying the principles of vectors here. So in the x-axis, we just say the same thing, right? Because in this direction, it was, when it was in this direction, it was moving with this velocity. This one, it has this velocity. Okay, which was defined. So we want to find the x component of this, which will be the same thing, but let's find how. So to find the x component of this, we just say f r v 1f cos theta. Okay. In this case, what is the angle here? The angle is 0. So it will be cos 0 plus. What about for this part? Well, for the second part, you have the mass is what? Is m multiplied by, we had forgotten this part. Mass multiplied by what? Mass multiplied by the velocity. Now the x, like, we want to find the x component for this part, this. Okay, how do we find? We just say, okay, the x component is v30, then cos theta. But what is the angle? This direction, the angle is 90 degrees. Plus mv3f. What is cos 90? Punch on your calculator and see if it will give you a value. Okay, so cos 90 is 0. So if this is 0, it means that everything here will be 0. Okay, so we have is equal to 2m is, okay, so 2m multiplied by, so what is this? Is this in this direction, right? So both this one and this one has got the same velocity, so it will be 30 multiplied by cos. What is cos 0? Cos 0 is 1. So 1 multiplied by this, it will be the same this. Okay. Then plus mv3f. Okay. So this by this, it will be 60 m plus mv3f. Okay. So we can keep this as our equation 1. Okay, we can keep this as our equation 1. Well, we also want to find our equation 2. Okay, so we can grab this. Okay, so yeah, we'll go to the y-axis now. For the y-axis, yeah, we're going to get the same thing. 0 is equal to m, yeah, everything the way it is. Okay. Just like that. Okay. So now we had this diagram whereby this one was moving this direction, this one. This was the m1, this was the m2. And the m1, okay, had a velocity of v1, right? v1f, then had the velocity of v2f, which were both 30. What is the mass of vf1? m1 is 2m. The velocity. Now we are in the x component. So for this one, we are in the y component. So for this one, what will be its y component? The y component for this one is given by what? It's just given by this same v. What? So what is this v? This v is 30. 30 multiplied by, 30 multiplied by, multiplied by what? By sine. What is the angle in this? That is 0, sine 0. What is sine 0? What is sine 0? Sine 0 is 0. Okay. Sine 0 is 0. So this part will be 0 plus. What is the, so for the second what? The mass is m. What's the velocity? Okay, in the y direction. So multiplied by, this is 30 times sine 90 plus mv3f. Okay, now I can get rid of this. Now I can get rid of this. What is sine 90? Sine 90 is 1. 1 by 30 by m, 30m. So 0 is equal to 30m plus mv3f. This is my second equation. This is my second equation, people. This is my what? This is my second equation, people. Okay. From there, I can make mv3 the subject of the formula. Okay. From there, I can make mv3 the subject of the formula. Right? Yes. Okay. So m1 was 2m, m2 was m, m3 was 3m. Okay. So from this equation, 0 is equal to 60m plus, what is the mass of this part, the m3? The mass for this part is 3m. Then that is a certain velocity. Okay. This becomes our equation 1, the final equation 1. Okay. Yeah, anything else? Anything else? Okay, so I think we are good to go. Good to go. Not yet, not yet, not yet. But we're almost good to go. 0 is equal to, okay, 30m plus. What is the mass for the third velocity? Well, we've been told that the mass for this one is what? Is 3m2. m2 is m. So the mass for this one, just like we have said here, is 3m. Right? mb3. Okay. Yeah, now we can say therefore. We can say therefore. Okay. Yeah, let's equate these two equations. Huh? Let's equate these two equations. So I can make this the substitute formula. So 3 mv3f is equal to negative 30m. So yeah. We have this. Okay, we can make this the substitute formula. But there is a question some people have been asking themselves. Say, oh, okay, it's still fine. Yeah. But some people have been asking themselves. Say, okay, but we are in the x-axis and we are in the y-axis. Yeah. Y-axis, x-axis. Amazing. Meaning that if these had like for the first one, v1, v2, if these we are using angles y, and we also using angles for this one, well, we are supposed to use angles also because it is the component. These are also the components. Okay, but for the sake of confusion, we now use the angles here, not them. But let's now replace because it is in the y. So we say 0 is equal to 13 plus 3m. How do we find the component for this one in the y-axis? The component for this one is given by the y component is given by sine theta, and it is the same theta that we are looking for. Okay, so this is simply an upgrade of the second equation. This one will also be upgraded because here we are talking about the x-axis, right? So how do we find the component, x component of this one? So we just say cos it, and this angle we don't know it. So now from here we can now make, for example, we can make v, we can make 3vf the substitute formula. Yeah, it's still fine. Or we can just say this goes to the other side, right? Yeah. So what are we going to have? So we have negative 30. Which one should we use? Which one should we use? Which one should we use, people? Which one? So about solving them simultaneously. Yeah, solving them simultaneously. Using any method of your choice. Yeah. Use any method of your choice. Which one is much more faster? Okay. Let's evaluate together. Let's evaluate. See what? Okay. So in this case, let's make this the subject of the formula. Then we come and replace here. You can use any, different ways of killing it, right? I always say that. Okay. Now what am I doing? So for this to be the subject of the formula, so this will come this side, yeah, is equal to, okay, clean, sine theta. Right? So we say over sine theta over sine theta, right? Meaning that these 3 mv3f will be equal to negative 8m over sine theta. Okay, let me lap that side. All right, can proceed. So this is it. So since this is the subject formula, we can replace in this equation. Okay, we have what? So we have got 0 is equal to 50m plus, then we have got this here. Okay, so where there is this, we replace with that part. Yeah, so this part will be replaced, so it will be plus negative 30m over sine theta. Okay, over sine theta. Okay, yeah, okay, make quote. Okay, still fine. Then cos theta. Okay, yes, and yes. So what do we have here? Well, cos over sine gives cot theta. So this can come to the other side, so we have the term cot theta is equal to 60 m. So you can get rid of these terms, right? Then over 30 cancel. Cot theta is equal to this into this. That is 2. Right. Cot theta, take note. Cot theta is equal to 1 over tan theta. Here, if we would have used this formula to make 3m the tabular formula, then we wouldn't have made cot theta, we would have made tan theta. But since we used it the other way, then yeah. So cot theta is equal to 1 over tan theta. So where there is cot theta, we'll place 1 over tan theta is equal to 2. Cross multiply. So we have 2 tan theta is equal to 1 over 2 cancel. Therefore, tan theta is equal to 1 over 2, which is 0.5. But we need to find the inverse. Okay? Yeah. Because we want theta, we don't want the tan. Huh? Yeah, we want theta, we don't want the tan. We don't want the tan, we don't want it. We don't want the tan. Where should I lab? Okay, I'll have this part. So therefore, alpha. Let me use the black one. Alpha will be equal to the tan inverse of 0.5. So tan inverse, what is tan inverse of 0.5, people? What is tan inverse of 0.5? Well, tan inverse of 0.5 gives 26.56505117. Remember, we see that the first one was moving in this direction, the second one was moving in this direction. Okay, where do we find tan as a positive? In the first quadrant and in the third quadrant. But in the first quadrant, you have got this and this, right? Meaning that we check tan in the third quadrant. Now, how do we find theta in the third quadrant? Well, theta in the third quadrant is equal to 180 plus alpha. In this case, we have 180 plus, that is the alpha. Yeah. Okay. So this is 206.6 degree. As the what? As the direction. Okay. But what about the magnitude? The size now. The size. So for the size, we can use either of the two equations. This one, which was the updated one. This one, or this one. Which one should we use, people? Which one? Which one should we use? Which one should we use, people? Which one? Well, I'm going to use. Which one? Oh, the one that made subject to formula. Okay, I'm going to use this. 0 is equal to 6m plus 3m cos theta. So I want to find this m. You can just get rid of them there and then, or you can bring this to the other side. Then you, you understand. You get what I mean, right? You get. All right. So you can move this now to the other side. Blah blah blah. Just one and the same thing. So you have 3b. If I know cos theta. So divide 3 cos theta over 3 cos theta. This. Therefore, what you want, which is the third velocity, or the velocity for the third mass, final is equal to what? Is equal to negative 60. So the angle, what is the angle? The angle found to be this. So you can just replace the angle. 206 point what? Use this one, people. This one. Okay. Don't use this one. But if you want, you can use this one. Okay. So we have negative 60 over 3 cos 206 what? 206 what? What's the answer, people? What's the answer? Multiplied by 3. Okay. So negative 60 over everything here gives 22.36067977. Okay. Therefore, people, wait, just wait. I know, wait, yes, just wait. Therefore, the magnitude is 22.4 meter per second. And the direction is in 206.6 degrees. Thank you so much for watching. Don't forget to subscribe for more videos.